Good morning, all my dear students, whoever joined here. Actually, very less students are joined. Only 20, 30 students are there out of 160. So let them wait for 2 to 3 minutes. Yeah, even they have to join. Okay. Just wait for 5 minutes because someone are still joining. Yes, fine. Uh, Dear all students, we were joined. So in the previous already we have started the lectures that computer organization and architecture. The subject name is computer organization and architecture. So in that already I explained you what are the syllabus we are going to study and what are the course outcomes, program outcomes, entire the detailed syllabus topics, whatever this semester in this semester journey we have to study well. All those things already I explained you very well. So today, after giving introduction, after giving brief history about the subject, today I have to start the actual syllabus as per university that is Solapur University, Solapur. Whatever syllabus prescribed, those as per syllabus, I have to start the first unit of computer organization and architecture. Okay. So before going to start the actual syllabus, one more time, just I have to refresh you regarding the subject. So this is the subject of your semester. See, I think all of you have this subject, right? So if anyone is not having this syllabus in the WhatsApp group, that is computer organization and architecture, in that group I have to save to you, I have to save to you that syllabus of your entire semester. Okay, so please you go through it. I think I have to dump it here. This is the TY BTEC syllabus. So okay, TY BTEC. Okay, so please you have to go through this syllabus for all the subject of your this semester, for all the subject of this semester. So same syllabus copy, I have to open it here now. So this is your syllabus copy that is PAH Solapur University Solapur, whatever they have to prescribe about the computer organization and architecture for the third year BTech second semester, computer science and engineering. All of you should must and should obey only this syllabus only. So many students are having confusing so many different editions of syllabus are there, but don't go for all those. Just you have to go for the syllabus whatever I have to send you now in the WhatsApp group, computer organization and architecture WhatsApp group. I have to send you a syllabus. Only those syllabus you have to follow this semester. Okay. And this semester subject code is CS323. 3 indicates third year and second semester of third subject, that is computer organization and architecture. So in this subject, all the things already I explained you, but now I have to directly go to the sub syllabus as per the section 1 syllabus. unit number 1, that is introduction of computer organization and architecture. That introduction part also I have to complete it in 1 or 2 lectures or 6 years. Okay, but just brief introductions I have to given you about. Please, all of you, make a mute. Please, all of you, make a mute. Okay. So as per today, I have to directly start with syllabus because already 2 or 3 lectures we spent in the introduction part of computer organization and architecture. So directly today I have to start with the syllabus from the unit number 1, brief history of computing. Brief history of computer. Today I have to explain and Van Neumann model generation of computers. Van Neumann model generator of computers. So these 2 topics today I have to explain and I have to cover as per the syllabus. Just you have to refresh it out. What are the today's topic? A brief history of computing and a the Van Neumann model generation of computers. So these 2 topics today I have to explain you. So for that, this is the PPT presentation what I have to made you. That is very College of Engineering prepared by me. Unit number 1, that is introduction, and that is a first lecture as per the actual syllabus. It is a first lecture for you. What are the syllabus we have to cover in this first lecture? That is brief history of computers. Brief history of computers and Van Neumann computers along with different types of generations. Along with that, different types of generations, we have to start with this. So for this unit number 1, I have to made you well defined notes also. So just I have to show you here is in this course plan. In this course plan of unit number 1, that is computer organization and architecture subject. Course plan of computer organization and architecture. In that first unit, the first unit is a introduction. As per our syllabus, first unit is a introduction. Up to that, we will go for some objective. So in this first unit, we will understand the different types of brief history of computers, and we have to get the knowledge about to performance of various evolutionary components of computer, and we are in that understand the need of that is need of advantages of computer. Okay, and after studying this unit, what are the outcomes we are expecting from the student? That is brief history of computers, and they have to well know about how the computer is going to be happen in the lifespan as in the olden days, and to understand the key feature performance of that related computer design and the explanation of to be more advanced technologies in the upcoming generations. Different generations we have to study, and we have to come to know that distinguish between risk and sys, and also we have to come to know between organization and architecture. After that, we have to summarize entire this topic with the computer performance and assessment. These are the things we have to study from the first unit. For studying this first unit, just you have a prerequisite knowledge about the fundamentals of computer system. So nowadays it is not a problem. Everyone is knows that what is the computer. Already you are played with the computer for your previous semester. So many labs, programs. Even you are very well aware of mobiles. Okay, this much prerequisite is more than enough to study this unit. After that, what is my plan? The plan for this lecture delivery, I have to deliver all the details of background brief history, and I have to explain in definitions like all the computer organizations is risk and difference between these many things. That is different generations of computer evaluation, technology used in stage evaluation, comparison of each like risk and risk, organization and architecture, and performance analysis in the technique improvement, all those things I have to give the delivery. So for this introduction chapter, there is no need of any derivations, procedure, experimental. That's what I have to put it as a not applicable. And also the physical meaning of the equations and calculations, nothing is there in this unit, because it is just about a introduction of brief history of uh, computer and van Neumann computer and different types of generations. For that, no equations and no calculations, that one I have to make it as not applicable. And all the unit wise I have to teach you in a very well manner. That is the fifth point. And in the sixth point, what is the final conclusions after this completion of unit, and how we have to put into the net cell. Net cell means what? In the real world scenario. Okay. And along with that, some important points we have to be understand, and we have to be keep in our memory in a long term. That is all the fifth generation, five generations of computer evolution. That is first generation, second generation, third generation, fourth generation, and fifth generation. After that, I will give you some questions. It is for your homework or assignment questions. That questions you have to prepare in your home. That questions how we have to prepare means how you, how much you are understood this subject. Okay. And final conclusions at the end of my lecture delivery, I have to give you some conclusion about this topic. Okay. So this is my plan how I am going to cover this in it. So if I have to give you a plan at beginningly, it is very much easy for you to understand entire frame or structure of this first unit. Okay. So this is the plan what I have to prepare. Along with that, please all of you follow. So from that, as per this your unit number one, brief history of computing. Brief history of computing, I have to explain you. So for that, history of computers, in that I have to make a topic of brief history of computers. Okay. So dear all students, everyone, you have to know that in the olden days, around 19 before 70 or 19 before 60, actually, the computer is started in the year of the work or the implementation or the production will be started in the year of 1940 to 50. Okay, but up to 1970, there is no that much lot of differences. But that time the computers are very huge size, very big size is there. So entire one room size, the computer size is there. But nowadays only we have to keep a computer in a single hand with a note, with a mobile, all those things. Okay. So just we will come to know the history in that. So that is the generation one, two, three, four, five, six. Okay. So first generation history is 1946 to 1957. The history of first computer they have to start at 1946 to 1957. That time they all use the vacuum tube. What the technology they are used in the 1946 means during the time of independence of India, independence of our country. That time the computer history, what is that? Actually the computer is vacuum tube computers, and this is having a transistor capacity, that operations capacity about 40,000, 40K. And in the next generation means second generation, it is almost about 1958 to 1964. So that time they have started to use the transistor. They have started to use the transistor instead of vacuum tubes. The new technology what they have to implement in the year of 1964. Before 1964, I mean 58 to 64, they have to started to use the transistor in the computer, and this is having the capacity of 2 lakhs, that is operations per second speed is 2 lakhs. After that, in the third generation, that is the history around 1965 to 1971. Again, they have to implemented new things in the computer, that is small and medium scale integrations they have to add it. These small and medium scale integrations, that is like a silicons, some silicons they have to add it into the generation of computer. Again, that is having a capacity of sorry, having a capacity of 1 crore. It is 1 crore of it to be having a capacity. Okay, that is the third generation. And in the fourth generation, in the third generation, they are used small and medium scale integration. But in the fourth generation, again they have to discover new things and implement it large scale integration. Only the small difference between third and fourth generation, only it is depends upon medium scale integration and large scale integration, which is a heavy capacity of 10 crore. You have to count it. And from the 1978 to 1991, 1978 to 1991, again they have to use very large scale integration, that is up to again having a more capacity of the speed. And in the sixth generation, that is 1991 to till 1991 to till, we call it as a computer sixth generation. We are using computer sixth generation, everyone, up to 1991 onwards to till date. That is ultra large scale integrations we are using in the current trend. That is the capacity of this much. You have to count it. Uh, how much it is? 10,000 lakh, 10 lakh, 10 crore, 100 crore. 100 crore speed of capacity is there. So it has become widely accepted to the classify computers into generations based on the fundamental hardware technology. And also each new generation is characterized by the greater processing performances in the brief history. So for that, this brief history, I have to make you slide as per your syllabus. So this is the history of computing, that is not a single breakout, okay, but the contribution of this many, okay, many peoples, it is helpful for the brief history of computing. So this is as per your syllabus, okay. So here you come to know that at the beginning, in the 1854 and all, before to launch the history, that is the one Babel's difference engine. They have to use it like an engine, this computer. And the first, this is the first computer. That is Babbage difference engine. That is the first computer. So just you come to know this history of this Babbage difference engine, that is designed by the Charles Babbage. That's what they have to call it as Babbage engine in 1854 to produce the tables of logarithms and trigonometric functions, and and it is a much faster and more reliable than the humans. So and it is not flexible, means could not only perform a few tasks, because that is the beginning history of the computer. Only few tasks it is going to be executed. That is Babbage's difference engine of the computer history. That is the first computer in the world. Okay. And today's lecture, I have to explain you a brief history of computers and hardware architectures, software, and programming languages, the 5 generations, all these 5 generations and workflow. I have to explain you for the today's lecture. So next one, the closest cracking the code. So at the previous, just you have to look into that. See, you may observe this. This is the black and white. That time there is no color, right? There is no color photographs, or there is no color videos or anything. Everything is black and white only. So for that, I also collected black and white pictures only. So this is the first computer, how the history is going to be started. So this computer is designed by Max Newman in the UK, United Kingdom during the World War II. What is the World War II? That World War II is in the history of 2030 to 40. Sorry, 1930 to 1940 history. Around it means that before our Independence Day, before our independence, they have to prepare this computer. That computer is prepared in the United Kingdom during the Second War, and it is used to decipher Germans also. And for this UK, whatever they are prepared, the first discovered that communication is between German to the UK, and that much faster than the humans. Just it is a much faster than the humans, and it is only to perform a few specific tasks again. Not flexible means it is not able to do the huge work. So because that is the starting point of the history, and one by one daily they have to add it here. And this is the Colossus cracking the code. That is Max Newman. They have to generate it. After that, one more history comes, that is ENIC. ENIC means see, the ENIC means it is a electronic numerical integrated and computer. Electronic. So here, electronic numerical integrated and computer, that the first general purpose they have to use it. So this is the size of that computer what they are used in the 1940. That is developed by the US Army in the 1940s. This computer they have to develop it, and the key features of capable of being programmed and for complex operations. So that is the loops, branches, and subroutines are understood by this computer, and it is used to computing the projectile trajectories, and also to develop hydrogen bomb, to make it as a hydrogen bomb burning, that is used for this computer. That computer is first general purpose ENIAC. ENIAC means, so here only I have to add. Okay, so it is nothing but electronic. Okay, electronic numerical integrated and computer. So I have to make to minimize the size. This is also just for 20. Okay, so integrated and computer. So this one is the developed in the US Army in the year of 1940s. So you have to just look into this because it is black and white. In those days, there is no color. So these are available. Still, it is black and white only. So this is the size of second computer. After that, one more scientist is comes. That is, he called it as a general purpose computing is based on the Van Neumann architecture. He is the Van Neumann actually. So he has to design it in such a way that CPU, input and output, and the memory. So in that Van Neumann, John Van Neumann, his lifespan is 1903 to 1957. So he can use the polymathematical functions made by the major contributions and the functions of physics, uh, economics, statistics, and computing. So these are the things he has to invented in the year of 1950. That is the first generation of the computer. So then Han Neumann architecture includes some standard components, that is central processing unit, input and output devices, and some key dimensions like memory separated from CPU, and it is able to store programs. So these are the main new features the Van Neumann is added into the computer in the history of 1950 to 54. Okay, that's what we call it as the first computer. We call it as Van Neumann architecture, or normally we call it as Van Neumann computer. So after that, that modern computers and hardware, once he has to design it with the CPU, with the input and output devices, with the memory, and that memory is also separated from the CPU, compute central processing unit, that is designed by Van Neumann. After that, this computer's structure is become like this. So that is modern computer science and hardware we call it as, because this computers is containing some software, that one we say hardware and software of a human modern computer. So this is the hardware of the physical stuff, and this is the software of the programs, whatever they have to build in. So here in the computer, some computer also still in the market they have to available. You may saw that the monitor of the computer size is like a TV. There's a big TV backside, big length is there. Okay, so same thing they have to use it on that day. So that is the screen. This one is the screen, or we say it is a monitor, and this is the speakers what we are using, and system in it. That is the system means central processing in it, and this is the keyboard. This is the mouse. This is microphone we are using along with the computer, and these are the speakers. Okay, that is all hardware part. At the first, the Van Neumann has to be invented. After that, what are the softwares? So this is the Outlook Express, the MS Office, the Excel, the Internet, the dustbin means the trash, and the Google Chrome, Adobe Reader, and these are the some videos and some users network purpose, and this is for Mozilla Firefox. All these softwares just they have to started to installed in the computer, right? That is the first generation of an human computer. Okay, so after that you come to see that this is the one. I have to show you an image to taken from one China organization. That time how the computer they have to stored, because in the history of 1950 to 1960 the computer means it is very new thing for everyone. Before that there is no word of computer, there is no device of computer, just they have to maintain manually everything. But whenever they have to start it with the computer, that is new for everyone, right? So for that, they have to store the computers in such a like that in the room that should be in AC room. So this is the personal computers, desktops and laptops, and it is embedded computers, special purpose processors embedded into the larger mechanical or electrical systems, and also they have to use it for phones, car, engine, washing machines, etc. Many things they have to use it. And the supercomputer, after that the supercomputers, that is a high performance systems, and current and top system, and Sunway, that is China, they have to call it a some specific name, just they have to pronounce it. This is the specific names what they have to use it for that computer. So after that, the modern hardware architecture of the computer is becomes like this. So this is the input devices, output devices, and the computer is having a main memory, that is memory in it, and arithmetic and logical in it, control in it, and central processing in it. Okay, so these are the things of the main components of computer, that is central processing in its CPU, control in it. It manages flow of data between the other models, and the arithmetic and logical in it. It can perform all the arithmetic and logical operations required by the software, and some computer memory. So this is the computer memory, that is CPU register, cache memory, level 1, level 2. This is RAM, and the physical RAM. virtual memory. So the storage device types. So these are the raw mind boss. That is devices we used here for the network purpose and for the mark devices purpose. So again, some input and output, that is keyboard, mouse, removable media, scanner, printer, source files, and other some sources are used. So whenever the computer is switched on, the CPU executes basic instructions and that are stored in the read-only memory ROM, and also the known as, we call it as basic input and output system, that is BIOS, basic input and output system. And we are using real programs are then transferred from the mass memory and high speed memory called as a RAM, read and write memory, that is holds the all the programs and data users to need immediately and executes whenever the RAM files and the CPU turns off. The virtual memory is going to be slower or it is going to be shut up. So the cache memory, we call it as a temporary memory, that is ultra fast memory devices is preloaded into the CPU needs. Okay, so this is computer memory. Up to that, the computer software, how the software is you started to use in the computer based on the programs. See here, this is the hardware, is nothing but our computer device, and here a user, between the computer device hardware and the user, we are using application softwares and system softwares. System softwares are nothing but operating system. Applications softwares are nothing but, for example, your MS Office, Adobe, a text file, all those. So in this operating system, it can manage the whole computer system, and after being fetched by the BIOS, automatically it loads basic programs such as graphical user interface. They have to use to start it, and examples of, for example, they have to use MS Windows, MS Office, Apple Mac operating systems, GNU Linux in olden days, but nowadays MS Office only you are using, right? And in the application side, word processor like MS Word, LaTeX, spreadsheets like MS Excel, LibreOffice, etc, you have to use it nowadays for the application side. And for the operating side, you have to use operating and application, both are very much useful for hardware device side, user device in the computer organization. Up to that, they have to started with some of the programming languages, that is programming languages used to design the communicate instructions, how to give the languages instructions, how it is going to be manipulated in the computer, that is programming languages. And that is defined by the rules of describing how to form a correct sequence of instructions. So the vocabulary of language keywords such as commands and other served words. So the some characterized they have to use for power, clarity, and portability. Power is nothing but how much the logic is contained in each line of code, and clarity is nothing but how it clears is the code from human viewpoint, and portability is nothing but how easily can it do the code of use in the portable way. Portable means easy manner. And last one more, that is power. So clarity and portability are used for classify the programming language side 5 generations. Okay, so up to that, now I will move to 5 generation. Okay, just a minute. Clarity, portable. Okay, so this is the power. Okay, this is the clarity first generation of language. So now, as per your syllabus, dear students, up to now whatever I have to explain, that's the brief history of computing, and that Van Neumann, and that is and human model. So next, I will move to the generation of computers. There are totally five generations of computers are there as per your syllabus mentioned. Five types of generation. Just we will go for this is the program language. At the end, we have to go for five generation. So that is first generation. We say it is first generation languages. Also, we call it as machine language. All of you, please be remember in your mind first generation language, first generation computer, we called it as machine language. We called it as machine language because a very primitive and closely tied with the specific hardware, and it is consisting of sequences of a zeros and ones. At the beginning, the computer which can understands only zeros and one, and the minimal power it can use, that is even basic operations require a long instructions. So nowadays just you have to use it for int float b and add some whatever differences because it is a C programming. But in that around 1970 to 60 to 70 history, there is no C language is also there. That time the computer is understand only zero and one. So for to understand a very few things, we have to write a very long instructions. That is difficulties. Okay, and in the clarity level, it is minimal programs are incomprehensible to humans. Incomprehensible means it is not going to be understand even abstract level also. Okay, and the portability, there is no portability because the huge big size computer is there that time. Big size computer is there that time. So this is the entire history of first generation, that is machine level languages, first generation. So come to the next generation. Next generation we call it as assembly level languages. At the first it is machine level languages, next it is the assembly level languages. So that is second generation languages of the computer. So this second generation languages, it is also called as assembly language. First one is machine language, second one is assembly language. So that assembly language I have to show you in this side one text. This screen also I have to add it. This one we called it as assembly level language, and this language expresses in the machine language in the words, and the power is also very low power they have to use it, and clarity is also low compared to current technologies, and portability is also no. So just first generation to second generation, what are the changes is happened? First generation we called it as machine languages. Same in the second generation we have to call it the assembly languages. We have to call in the assembly languages. Next we will come to that next generation, that is third generation. In the third generation we call it as high level language. Machine level language first generation, assembly level language second generation, and in the third generation we call it as high level languages. That high level languages are writing like this, very huge code. Okay, so in this high level languages, it may comes under C programming, C++ programming, Fortran, and the power it is uses very high power, and clarity is medium. So previously you check it, that is machine level language and assembly level language, there is no that much clarity and that much not portability. Portability is totally zero, clarity is not there, and power also very less power they are using. But second generation to third generation, whatever the changes is happened, especially the third generations are nothing but that is C programming, C++, and Fortran. So power is using high thing and typically corresponds with the machine level instructions, and clarity is medium compared to Assembly level languages, the clarity is medium, and the human experts can understand code rather than easily compared to machine languages and assembly languages as per first generation and second generation. So compared to these two generations, third generation is far better in the history of 1980 to 1990. Okay, and portable is also a medium. Okay, so it's something good portability is there for this third generation. After that I will go for fourth generation. So in the fourth generation languages, almost whatever the previous languages you have to use it as high level languages and combine computations with the visualization and high these four generation languages are nothing but the MATLAB they have to use it in the history of 1990 around and 1990 onwards and the Mathematica one more they have to use it, but majority of they have to use the MATLAB and Maple and Java, all those things they have started up to the history of 1990. So actually the Java they have started in the year of 1990, but actual Java they have to implemented in the year of 1996 or 97. Around 2000 to 2005, the Java becomes a very much popular language in those days for the softwareical things that all are comes under the fourth generation of computer. So here power is high, clarity is high, portability is high. So you have to check these parameter with the previous generation like third, four, two, and one. So here the drastic development is happened in the fourth generation of the languages. So after that, I will go for uh, fifth generation. So especially up to the your syllabus, the fifth generation they have to put the syllabus generation one to generation fifth. So in the fifth generation languages, we call it as 5GL generation language. So here everything is going to be digitization in the fifth generation. After 2005, we call it as fifth generation. So the input that problem conditions to be met expressed in the natural language and the 5GL means five generation language automatically produce program to solve a problem and the program becomes a redundant. So in this technology, mostly used in the artificial intelligence researches, and it is despite decades of research, still not much progress, and the human insight and institution can be replaced in the fifth generation. So whatever the history of computer from 2005 to around 2020, those generation we have to call it as fifth generation of computer. Okay, after 20 onwards, sixth generation they have to start it, but still it is not in the market, but practically work and implementation is going on in the sixth generation. So that is the we will study it in the later, but up to as per your syllabus, up to fifth generation you have to study. So just I have to recall in the 1 minute. First generation, that is machine languages. Second generation, that is assembly languages. And third generation, that is high level languages like C programming, C++, and Fortran. And fourth generation, that is like Java, C Sharp, .NET, all those things. That's the fourth generation. And fifth generation, whatever right now we are using new technologies, some new features or ideas implemented in the fourth generation, and they have to started with the new generation that is Springs, Hibernate, Struts, all those things. Okay, it's available in the market. That is called as a fifth generation. So all these history of the generation as per your syllabus. So this PPT I'll send you and notes also I'll give you. Don't worry. So today's I have to cover brief history computing and Van Neumann model, all different types of Van Neumann model and generation of computer. So okay, dear students, uh, and one more I have to take that is system bus and bus model. Just a minute. Yes, okay. So next, here I am using, just a minute. Yes, fine. So next, as per your what do we say, syllabus, that is system, the system bus model. So in this system bus model, already I explained to you in the microprocessor ADT. See, okay. So in the after all the generation, there is we have a, to increase the capability of to solving the computer problems. That problem solving with the computer, that is nothing but initial setup data, problem to solve, and what can be done in the data, and what states can be achieved using the existing tools. How to the to be answer to be found, all those things is able to do the next generation. Okay, so for that the computer program can be seen as a logical component, and that transfers in a input state into a new state from which the solution can be found it. Okay, so this is all about the generation. Now I will start with system bus. So this is the system bus. This is the system bus. So in this system bus containing input and output devices and the memory. That memory may be a ROM memory or read and write memory, and the arithmetic and logical units, register array, and control unit. All these different control, like control unit, ALU, register, input and output, ROM, all the memories are internally connected by bus. That bus we called it as system bus. The bus is nothing but it is a data transferring agent. The data should be transferred from source to destination or one place to another place. That transferring agent, we call it as system bus. We call it as system bus. And this system bus having a uh, three categories: control bus, address bus, and the data bus. So by using all these control bus, data bus, and address bus, we are going to communicate between central processing unit, memory like a register, and input and output devices. So dear all students, this much we have to study today. So that is system bus and types of bus. What are types of bus? Control bus, address bus, and data bus. So dear students, just today I have to cover this much very small topic, and this PPT I will send to you. Notes also I will give it to you. Uh, just you have to go for this today's topic, whatever I cover. That is a brief history of computing, the Van Neumann model, and the generations of computer, the system bus, the system bus model. System bus model, already you are aware with that. Many things I have to cover in the microprocessor, and today also I will replace it to you. And in that notes also I will give you in the clear. Okay. So this much the today's topic, and today just a minute, all of you wait. I have to take your attendance. I have to want to take your attendance. Just cooperate me. Today is 17 March 2022. Okay. So dear students, today no one is there for the offline class 5. So just a minute, from the A division. Please don't log out. I have to take your attendance. See, some student TYB65. 65. Okay, fine. So, dear all students, today no one is attended offline classes. So better try to attend offline classes, and maximum you have to avoid online classes. Okay. If you are not in the situation of to attend offline, you can attend online, no problem. But try to attend online offline classes. Majority of the students. Okay. So this is my suggestion. And today, just very few topics I have to cover. That is brief history and Van Neumann model and all the different five generations and system bus model. So this entire again one more I have to complete this. After completion of this first unit, I will give you complete notes also. Don't worry about the notes. As you were in previous semester, I am handling the microprocessor. That time how I have to provide the notes like that. Again, I am preparing the notes and I will give you. Okay. So, but only thing is that whatever I have to cover day by day, you have to complete your study on that day only. So all of you go through the syllabus. Today I will send you the syllabus copy also in the computer organization and architecture. So go through the syllabus and as per the syllabus we have to do the study. Okay. So thank you all for the today's lecture and we will continue with the next lecture. Please you have to go and attend for your next lecture. Okay. So thank you all. Now you can leave the meeting.